Hello, this is Dr. Lukes, and this is the solution to exam 3. All right, so next let's look at question 3, the last question. And this first part asks for what is the free moisture content at the end of the drying period. We have the equilibrium moisture content given, and we are told that we want the final total moisture content to be 0.112. So therefore, the free moisture content is the total minus the equilibrium. And all of this is moisture content on a dry basis, so 0.12 minus 0.05 is 0.07 kilograms of water per kilogram of dry product. Now the next question asks, assuming that this is diffusion dominant falling rate, estimate the total time required to achieve this final product. Now we have two equations that we can use. We have T equals 4x1 squared over pi squared diffusivity log of 8xc over pi squared x. And we also have LS over A delta X over delta rate, natural log of the rate 1 over rate 2. Now the issue with using this one is I don't have the units on R, so I'll be really hard pressed to come up with what the units are for time. I mean, I might guess what they are, but I don't know. The graph does not give that. So I need to therefore use this first expression. X, the lowercase x, is the thickness. And since this is being dried on both sides, it is 0.0005 meters, right? Half a millimeter, half of 1 millimeter. And then turn that into meters. The diffusivity in the liquid phase is 1.28 times 10 to the minus 9th meters squared per second. I do want liquid, that's what the L's representing there. X sub C is where we start going down to the falling rate. And that is 0.25 minus 0.05, right? These are supposed to be free moisture content, so 0.20 is X sub C, and X is where I stop, so that is 0.07. And if you plug these in, we get 66 seconds, or at least that's what I got. And then we're going to add that to 4 hours from before, so therefore it's going to take about 4 2/10 roughly hours. Now, based on this information, this means that the falling rate period is trivial compared to the other. These numbers, I'm going to tell you, don't really work out all that well. Now, not that realistic. The last part here is to explain why the diffusion dominant falling rate drying was or was not the appropriate model. And so I'm looking for two things. Is this diffusion dominant? And is this linear falling rate? And if you look at this, it does appear to me that I can fit a line through that data fairly well. So it appears to be linear. And it also does appear that starting about somewhere in here, so maybe it was as early as 0.25, but it does seem like I have now, after 0.25, moved into the linear. So or moved into the falling rate. So basically, I just want you to describe what you observe in the graph, and that based on the observations from the graph that this does seem to be appropriate. So this concludes our exam 3 solution. Thank you very much.